Xiaoyang Liu from Material Science and Chemical Engineering will talk about studying molten salt corrosion enables future nuclear power plants.
Fukushima nuclear disaster. The most severe nuclear accident happened on March 16, 2011. 3 hydrogen explosions released radioactive contamination to nearby region, forcing over 100,000 people leaving their homeland. A serious question immediately comes to human beings. What can help to make a safe and reliable nuclear energy? You may never think the answer can be adding salt into nuclear facility, which has been discovered in 1960s. When the salt is heated to molten state, like liquid, it's an effective heat transfer fluid to be applied in molten salt cooled or fueled nuclear reactors, which prevents nuclear meltdown to avoid explosions like what happened in Fukushima nuclear accident. However, on the other hand, a problem is molten salt also introduce corrosion on container or pipeline metallic materials, forming voids or cracks that may cause the radioactive molten salt leakage. My dissertation is aiming to understand how molten salt damages metals. I conduct the experiments by intentionally immersing the metallic materials into molten salt, observing the voids grow in metals over time. The change of metals is not just from a simple chemical reaction. It also results from the movement of items on metal surface and transportation of ions, which is the product of items losing electrons in molten salt. By calculating the corrosion distance, I found that the transportation of ions is the key step controlling the speed of molten salt corrosion. My work is the first time observing the metal corrosion in molten salt in real time, providing a fundamental understanding. Moreover, I extended my experiments to a range of temperatures and proposed a different corrosion mechanism based on observing various pore growing processes. Besides internal shape change, my study also shows that the metal items rearrange during corrosion, changing atomic structure of metals. This study opens a new perspective to understand metals corrosion in molten salt from the change of metal structure. Overall, my research, observing the metal's behavior in molten salt, provides important data and proposed corrosion mechanism from shape and structural change, helping to develop corrosion mitigations, such as designing structural stable metals. Over 100 years, people face environmental, climate, and health issues because of using fossil fuels. I believe my research enhanced comprehension on the corrosion mechanism, guiding the development of safe nuclear facility with zero emissions and producing carbon-free electricity.